In this video, I would like to run you through the process I would use to create such an object inside Alias. Well, Alias is of course known for its surfacing tools to make products or car bodies with a really high quality and precision. It also actually has a pretty decent set of CAD-like drafting tools, I would say. So let's go back to Alias. What I'm going to do first is actually set up my work environment. So I go to construction and I can make sure that I work in CATIA. That's also just for future reference. This, for example, sets my fitting. I want this one to be 0.001. If, for example, I go to user defined, most times this is actually there. But I can also, if I want to work with user defined, simply take a look at the CATIA one and then, for example, adjust it. But easiest one, CATIA. Okay. Number 2, I can go to general preferences and go to modeling and set this one to 0. Simply every time when we're going to work with the key point curves, every time when I draw one, we're getting guidelines and I actually don't want them. So I set this to 0. So they're not being created. Okay. Good. So our blade is roughly 62 millimeters wide. That means our grid spacing is not really suitable. Let's go to here. Currently, one cube is representing 10 centimeters. It should be 1 centimeter. So we set this to 10. And instead of just seeing the centimeter, I also would like to see the millimeters. So I subdivide that centimeter into its lower units. Let's take a look. Okay, but now the grid is way too big. Maybe we can actually shrink this one down to 70. This is, for example, the size maybe that's more appropriate for a part. So there, let's zoom in. And then you can decide if you're going to work in side view or top view. Honestly, it doesn't really matter. Maybe go to side view. That might make more sense because our other part we might draw attached to it as well, the handle. So let's go to the key point curves. Let me close all those parts here. And right click, key point curve toolbox. Let's make it smaller. And there it is. So I know that the lower base of my object is 62 millimeters wide. So I can click on this one and then with Alt key, so snapping to the grid, I click and click to somewhere else till, for example, I get 62. Okay. And then maybe I can move this one. I know that the top base, for example, is roughly also kind of like 32. Yeah, 32 millimeters. So I make myself another line. For example, I click, drag this one out. And if you need to adjust a line afterwards, and that is the beauty of the key point curve tools, you simply go to the information window, open it, go to attributes, and based on what type you have, currently we work with a line, you see the length. So there, for example, I can type in 32, and then from the origin point, the line is going to be extended. So for example, what else could we do? Yeah, let's maybe reset the pivot point. Because I work in millimeters and my object fits into the millimeter grid, I was able to reposition this the pivot point comfortably onto the midpoint of this line by actually using the grid. So I didn't need to worry more. And then actually For example, I center position this one. Now, the line vertically down, for example, is roughly 19 millimeters. So I could go to the line, click, alt click, and then drag a 19 millimeter line down. So I know, for example, now where this base has to go to. So I can select, whoops, select nothing, select object, select my part, go to move, and then actually with the grid move it up. And I'm just repositioning the pivot point position till my midpoint, you see, along the z-axis is actually snapping. Now, if you do not necessarily have everything set perfectly to the grid, I can also, for example, use the pivot point. And FYI, I have my snap subdivision set to 2. So for example, if I Control Alt click onto the line, you see those blue markers. I can snap to the center of the line, the midpoint. Okay, then I can go move. Now I click Alt and Control, click on this line, not next, on this line. And for example, drag it down till it doesn't go further. You see where my mouse is. Release my left mouse button and it's perfectly positioned. Okay, oops, don't move it afterwards. Select nothing, an object. And then, for example, we could snap to the curves and, for example, punch in the lines for the sides. This, for example, is now kind of like the basic proportion of our outline. So let's take a look at actually what we have left. So for example, this cutout, my blade actually has 2. So the distance is 4, the height is 4. That means I have 2 millimeters vertical sides and then an arc with a radius of 2 millimeters. And I have 2 of those, and there's a 3 millimeter gap between. So I can go, for example, somewhere else, because now I work with millimeters and 3s. So I'm going to create myself first, kind of like a helper line, snap to the grid, and I make this one 4 millimeters. I make another line 2 millimeters and 2 millimeters. And now I have to create an arc. So there are actually multiple ways how I can create an arc. So for example, click, and now it's a 2 millimeter radius. So I can actually click on this point because it's 2 millimeters and click, for example, one way. Let's take a look what we have. For example, here we decide the start and end point, and then actually the center. See, also the same. Works as well. So there are actually multiple ways how you can actually create this arc. And they're all at the end becoming just an arc. Let's actually take a look at the information window again. When we select this arc, you see now we have the radius. We can change it. We can, for example, change the degree. Let's delete this one. Let's go back actually to this one. 1, 2, and 3. Let's change the radius again. Yep, see, no matter how you draw an arc, once you edit it, it's just the same arc, and when you change them, they all behave exactly the same. Perfect. So this whole thing actually has a 3 millimeter gap, so I create myself a 3 millimeter line in between, just as a helper. And then I'm going to select those, copy and paste, and move. And then I am in orthographic, so left mouse button. Oh, nope. Bad. Okay, so you saw what happened. I snapped to the grid and it all became terrible. So what I'm going to do now with those objects selected, I simply can go to group. Now it is a new group. The group has its pivot point always at the center down there at the moment. So I'm going to, maybe I don't have to, but I'm going to recenter it to there. So I can easily, middle mouse button, snap it to where it needs to be. And then I can go and ungroup and I'm back. So instead of resetting the pivot point for all curves, then because it's reset, I can simply create a group and I'm good. So this line I don't need anymore. That was just a helper. And then I'm actually selecting all those and create another group, because now actually I need to position this 3mm line on here. So middle mouse button, Control and Alt and left, and I'm clicking on this line because I want to snap the pivot point right to that center. And then move, and then Alt, and I snap to the grid. So the pivot point I snap to the grid because I put the pivot point at the center of the line. My drawing perfectly is centered to my object. And I can Command U, undo the group, so ungroup it. Good. So that so far is, for example, the side detail. Now our blade has a 2mm, it has a 1mm thickness, and there is going to be a cutting part. So we can take maybe care of that one. So now you see I have a 1mm block. Later we're going to extrude the surface out this way. So I know that maybe there I need a little bit more of detail. So I changed my subdivision to 20. So now I see exactly the millimeter, half millimeter, millimeter, half millimeter breaks. Great. So 4mm. This is now hard to see. So I'm simply creating myself, click and click, a helper line to judge the height. And maybe this one I can simply move over. So here I will have a V. Now, for where I'm going to start to draw is actually really important. I'm going to draw Alt click and Alt click, Alt click and Alt click, a line this way. Let's delete this one and let's take a look. Why? The main reason is later we take those vertical lines, extrude them into a surface, and then, for example, cut our metal master to get this cut shape. But the problem is always when a surface ends right on another surface. Sometimes the software can have difficulties figuring out how those two surfaces intersect or where they intersect to cut. So best is actually to always make surfaces longer so they overshoot. So this means while this is now the height of 4mm, I might need this line to be longer. And the beauty of having drawn everything from the point is I can go now and simply say 6mm, and you see that it keeps actually the starting point and extends the line. Another beauty of key point curves in Alias. They're really nice for this type of CAD work. Okay, I think this actually covers nearly all of our design work, putting down the lines. Maybe what we should do is actually move them to the right. So middle mouse button, and let's go. I put it sufficiently away, kind of like somewhere there. Perfect. Okay, let's save. And let's organize our design a little bit. So those are key point curves. I'm going to create a layer. So for example, I call this curves and assign. So I can always turn them off. I'm going to create another layer and maybe call this one dimensions. And let me show you how the dimensioning tool works. In AutoCAD, dimensionings are called annotations. In other programs, simply dimensions. And in Alias, they are called locators. They're here. And you have distance, angle, radius, diameter, and other things. So let's, for example, add a distance. Now, you can click and click and measures a distance. And then you could go to the move locator. Yeah, exactly, locator. And just, for example, maybe snap it to it. You can click on this text and move it away. But the problem is if actually we select this line and maybe move it, the locator doesn't move with it. Because the locator is just freely created, it does not actually, how can I say that? It's not linked to that line. If you want to have a locator that's linked to a line, you simply have Alt and Control and then click on the line. You see this white marker, that's the start. Click again, that's the end. And then actually when we select this line, you see it moves with it. Also, you might have seen that. You see, middle mouse button, Shift Control, move, rotate, Control Shift, left mouse button, nothing, object. The marking menu is gesture based. So I select the CV, I select nothing, I select object, I select surface. So if you memorize the direction and you simply, for example, Shift Control and then move your mouse with the left mouse button up and release, then actually it understands you wanted nothing. If I go Shift Control middle mouse button and up, I know that's where the move is, move. So you see now I can select this one, no, object, move, there. So that's a very nice way to quickly select partial tools when you really know what direction you have to go to. So this one, for example, we can maybe move out a little bit. You can also, for example, measure half a distance on this line if you want to. So 31. Okay. Let's put on another locator there. So what's the point of locators? First, for you, you can always put down information about dimensions. Now this is of course a very simple object, but imagine you have a more complex design, multiple parts. You don't want to always have to measure something. So you create yourself the time to simply draw the stuff onto it. I'm actually curious if we can also create a locator. Yeah, we can. Perfect. Between two different lines. So now I just have to make sure, can I snap to the grid? I cannot. Oh, that's a bummer. Okay, well I can snap this one to the midpoint of this curve there, and snap this one to the mid curve there, and then simply move this locator to the side so I see the exact distance of 19. This also means this line I can remove. I don't need it anymore. I have some smaller lines down there. So for example, Alt click and Alt click. There I have my distance, maybe the height. This one is not really well placed, so I move it to there. Actually, this might be too much information there, so I'm just putting this one maybe to there. There. And this one I can keep inside, or I move it to here. There, but no, this reads easier. And for example, if I want to, let's put in a radius. We can't use a diameter because this is an arc, so we need radius. So you click, you can rotate it, go to locator, you can rotate it, and if you zoom in and you click on this line, then actually you can extend it. If you click on the arrow, you can move it. Maybe make this one a little bit even so it's not too chaotic. Okay, that actually nearly documents our design sufficiently. Because also think about, maybe you give this one to an engineer or somebody to build. They don't just want to see your drawing, they want to see the dimensions. So let's line this one up neatly. And okay, which means this one should go to somewhere else. No, this locator looks terrible because the number is there, but you get the idea. Maybe let's put this one to there. What about inside? There. This looks better. There. Good. So that is drafting 101. How to place your key point curves and then how to dimension them in Alias. The nice thing about this stuff is, now you see when we rotate, all those lines actually rotate for you as well. So they're always going to be very, very easy to read. The other nice thing about those lines is because they are actually dynamic. If I select this line, you see this is magenta. So that means that this locator is actually, it has a, think about construction history to this line. And if we change this line, oops, wrong one. Oh, it was up there, I didn't see it. And for example, say this should be copy, maybe 5. There, it adjusts. So that's actually fantastic. Okay, so that's basically, I think, everything that's worth mentioning about the key point curves. So for example, the last thing that's maybe left is this part here. So here, for example, we could maybe make a line with the grid, and I'm trying to make this line, for example, line up with those here. So let's select the line there and then move it over. Okay, let's rotate, simply because then I can create a distance for here. So for example, I understand maybe all the time where the height value actually should be, and this is 4.5. That's actually not what I need. This is actually a good exercise. So you see how I'm simply adjusting this line for, and then 4 millimeters. And what did I do? Now that's interesting. It should have actually there. Okay, then we move this one to there. There. So maybe in this case, actually, I leave simply this one in. But now we can measure maybe the length. So I think those lines, yep, they overlap. So I should be able to Control Alt, and we see where they intersect. You see this magenta line. Now it's yellow. Again, this stuff actually project intersections. There I can measure this distance. So this line is actually based on the angle, the length 4.03 millimeters. So it doesn't really add that much. And then maybe this one is a little bit confusing. So I'm just snap it maybe to there. Okay, I think we're good. So this is perfect. Now to select all locators, you can go to pick. I select all locators, and then actually I go to dimension, assign. And then the nice thing is I don't want to see them all the time, but if I want to, I can show them, I can hide them. The same like with the key point curves. Try to always structure your designs so that it's going to be easy to show information you need and not get confused. And for example, like when we create surfaces, you want at one point then when we have the surfaces to hide all the stuff because you don't want the surfacing tools by accident continuing clicking on these lines.